Hello students, we are here with E-Maths class, Fatima Convent High School, myself Dipali. Moving further with the lectures of Chapter 1, Real Numbers, Class 10. We are going to start with the topic of Fundamental Theorem of Arithmetic. Now what is Fundamental Theorem of Arithmetic? This theorem actually you have unknowingly already studied in your lower classes like the Euclid's division algorithm. The fundamental theorem of arithmetic is simply the prime factorization of any number. We know that any number, a composite number, is made up of more than two factors. For example, 2 has a factor 2 and 1. That is a prime number. So it has only two factors. But 4 is having factor 2 and 2 and 1. It is a composite number. Same way, 253 has a factor 11 and 23 and 1. So it is a composite number. Similarly, the fundamental theorem of arithmetic, if we take an example of a larger number, say 32760, then we can factorize this as 32760 as a multiple of 2 into 16380, which further factorizes to 2 into 8190, again 2 into 4095, which factorizes to 3 into 1365, and that factorizes into 3 into 455. That factorizes to 5 into 91, which factorizes into 7 into 13. So we can say the prime factors of 32760 are 2, 2, 2 into 3 into 3 into 5 into 7 into 13. That is 32760 is equal to 2 raised to power 3 into 3 raised to power 2 into 5 into 7 into 13 are the products of prime numbers. Now the fundamental theorem of arithmetic states the similar thing. It says every composite number can be expressed or factorized as a product of primes. And this factorization is unique apart from the order in which the prime number factorizes. It can never have two numbers same factorization. So it says that given any composite number, it can be factorized as a product of prime number in a unique way. The prime factorization of natural number is unique except for the order of its factor. In general, given a composite number x, we factorize it as x is equal to p1, p2 till pn, where p1, p2 and pn are primes and written in ascending order, that is p1 less than p2 less than pn. So 32760 can be written as 2 cube into 3 square into 5 into 7 into 13. Now this fundamental theorem of arithmetic has various applications. Let us see what it is. Consider the number 4 raised to n, where n is a natural number. Check whether there is any value of n for which 4 raised to n ends in the digit 0. So when I say 4 raised to n, if I have any number which gives me 0 at the end, then that should be divisible by 5. That is, prime factorization of 4 raised to n would contain the prime 5. This is not possible because 4 raised to n is equal to 2 raised to 2n. and so the only prime in the factorization of 4n is 2. So the uniqueness of fundamental theorem of arithmetic guarantees that there are no other primes in the factorization of 4n, and so there is no natural number n for which 4 raised to n ends in with the digit 0. Now another application is to find the LCM, that is the least common multiple, and HCF by the method of fundamental theorem of arithmetic. This method is also known as prime factorization method. Now let us study this. Now we know that the fundamental theorem of arithmetic says every composite number can be expressed or factorized as the product of primes, and this factorization is unique apart from the order in which the primes occur. So in general, we can say if x is a composite number, x can be written as p1 into p2 into p3 into p4 till pn, and the order is ascending, that is p1 less than or equal to p2 less than or equal to p3 less than or equal to till n. Now there are two methods of prime factorization. The first one is tree method, that is, suppose we take an example of 196, then 2 into 98 gives 196. Now 98 factorizes to 2 into 49 and 49 factorizes to 7 into 7. So 196 is equal to 2 into 2 into 7 into 7. That is 2 square into 7 square. Now the division method we are all familiar with is 2 divides 196 by 98. We get 98. 98 divided by 2 gives 49, and 49 divided by 7 into 7 gives 49. So the prime factors of 196 would be 2 into 2 into 7 into 7, that is 2 raised to 2 into 7 raised to 2. These are the two methods. Now let us see how it helps us to find the LCM and HCF of any given number. Before that, we need to know a clear definition of LCM and HCF. LCM is the highest common factor, which we already studied when we did the Euclid's division lemma, and we saw the various methods to find HCF. Here is one more method to find HCF. Now HCF is the product of smallest power of each common prime factors in the number, and LCM is product of greatest power of each prime factor involved in the number. And a formula can be formalized as for any two positive integer a and b, HCF of a and b into LCM of a and b is equal to a into b, which is also termed as product of two numbers is equal to its LCM into HCF. Now let us take an example, say number 96 and 404, finding the LCM and HCF of these two numbers. Now let us first factorize 96 by tree method or prime factorization method. When we factorize 96, we get 2 into 48, 2 into 24, 2 into 12, 2 into 6, 2 into 3 and 3 into 1. So prime factors of 96 are 2 raised to 5 into 3. And prime factors of 404 are 2 into 202 into 2 into 10 into 110 into 1. So 404 is equal to 2 raised to 2 into 2 raised to 10. Therefore, HCF of 96 and 10404 is equal to product of the smallest power of each common prime factors. Now the common prime factors are 2 and the lowest power of 2 is 2. So the HCF is 4. Now applying the formula HCF of ABC into LCM of ABC is equal to A into B. Therefore, LCM of ABC is equal to A into B upon HCF of A into B, which gives me 96 into 404 upon 4. When I solve this, I get 9696 as the LCM of my number 96 and 404. So did you see how the fundamental theorem of arithmetic is utilized at various places? Yes. Now we have one more formula to be studied. In case we have three numbers, can this formula be applicable? Yes, it can be applicable. Let us see that formula. Now, for the LCM of three numbers, we have HCF of PQR into LCM of PQR will never be equal to the product of P into Q into R, where P, Q and R are positive numbers. We need to apply another formula for that. LCM of PQR is equal to P into Q into R into HCF of PQR upon HCF of PQ into HCF of QR into HCF of PR. So, you will first find the HCF of two numbers, then the second two numbers, and then the last two numbers. We take an example, say that three numbers are 96, 404, and 24. Then, first we will be finding the HCF of 96, of 24 and 96, then HCF of 96 and 404, HCF of 24 and 404, and HCF of 96, 404 and 24. And then we can apply the formula. So that is LCM of 96, 404 and 24 will be 96 into 24 into 404 into HCF of 96, 24 and 404 divided by HCF of 96 and 24, HCF of 96 and 404, and HCF of 24 and 404. Can you apply this formula? Yes, it's simple to apply this formula and find the LCM of three numbers together. I suppose this topic of this chapter is clear. Now you would be able to do exercise 1.2. We will be meeting again with the next topic, that is irrational numbers or proving certain numbers as irrational. Thank you.